Hello and welcome to Mathematics with Simon. I'm Simon. Today we're going to look at the fascinating subject of surds, which lies in the A-level syllabus. What is a surd? Well, it's an expression that involves a square root that does not come out as an integer or a whole number. So for instance, the square root of 2 is a surd. It's 1.414213 dot dot dot. It goes on forever, so it's not an exact whole number. The square root of 3 is 1.732050 dot dot dot. So square root of 3 plus 1 is 2.732050. But again, it's not exact. So square root of 16, you could say that's a surd, but you can immediately calculate it just to be 4. It's not really a surd. We've got some useful rules here. So the square root of a times b equals the square root of a times the square root of b. And the square root of a divided by b equals the square root of a divided by the square root of b. Look, I just fixed the graphics there. Square root of a divided by b equals the square root of a divided by the square root of b. There was an extra space in between times and root b, and it was bothering me. Okay, these rules allow us to simplify surds. So for instance, the square root of 48 equals the square root of 3 times 16 equals the square root of 3 times the square root of 16. Square root of 16 is 4, so it's 4 times root 3, and that's a lot simpler than root 48. And also, actually, we can look back and we know what root 3 is, 1.732050. So actually, you could work out 4 times root 3 without even using a computer by just multiplying those two. Whereas it's unlikely that we know what root 48 was. Root 128 equals root 2 times 64, which is root 2 times root 64. Root 64 is 8. So this is 8 times root 2. Here's a quotient or a fraction, root 128 over root 2. We're going to write root 128 as root 2 times root 64. Cancel the root 2's, divide top and bottom by root 2. We just get root 64, which is 8. Here's another one, root 3 plus root 300. So the root of 300 is the root of 3 times 100, or 10 root 3. So root 3 plus 10 root 3 is 11 root 3. Here's a more complicated one. We're going to expand these brackets. So 1 plus root 3 times 4 minus root 3. If we multiply the terms, we get 4 minus root 3 plus 4 root 3 minus root 3 times root 3. Root 3 times root 3 is just 3. So this is just 4 minus root 3 plus 4 root 3, which is just 3 root 3. And then 4 minus 3 is 1. 1 plus 3 root 3. Here we're going to rationalize the denominator, so we're going to multiply the top and bottom by 1 minus root 3 to get rid of all the surds on the bottom. Now, the reason we want to get rid of the surds on the bottom is A, because it makes it simpler to understand, and B, because we might be able to add or subtract it to different surds, and then perhaps take a common denominator, which is easier when the denominator is a whole number or an integer. So we're going to multiply top and bottom by 1 minus root 3. On the top, that gets us to 2 minus 2 root 3 plus root 3 minus 3. And on the bottom, what happens is the root 3's cancel out, because you get 1 times 1 is 1. Then you get kind of 1 times minus root 3 is minus root 3. Root 3 times 1 is plus root 3. And then you take away root 3 times minus root 3, which is just 3. So it's basically 1 minus root 3 plus root 3, they cancel, minus 3. So what's interesting is you actually get, on the top, you get minus 1 minus root 3. On the bottom, you get minus 2. So if we just cancel all the minus signs, divide the top and bottom by minus 1, get rid of all the minus signs, that ends up as 1 plus root 3 over 2. And actually, miraculously, we know what root 3 is roughly, 1.732050, right? We know what root 3 is roughly. So what that then means is we could actually work out the top roughly and then just divide by 2. So it would have meant we'd done that whole thing, 2 plus root 3 over 1 plus root 3. We could do it all with a pen and paper. Or in an exam where you weren't allowed to use a calculator, for instance. Or just, it's good to have that power to be able to do things on your own and understand why it's happening. I really hope you liked this video. You're very welcome to subscribe and hit the notification bell. I'd love to hear your ideas, and most of all, I hope you enjoy your mathematics.